So when we open Focus Point for the first time, we'll be presented with areas for plotting, for processing our data, and also for managing the different data that we've imported. So the first thing we need to do is open our data, which we do by pressing the Open File button. Now we select one or more files. In this case we'll select 3, and it's going to ask us what the line sampling is for our data, how fast in hertz the scan rate of the laser was, and also the pixel dwell time, how long it was dwelling in each location of the scan. Now it's going to ask us if we want to use these parameters for all of those files that we just imported. In this case we do. And then it will work through each of these files, importing them to the software, and you can see the progress down here. Now we will only see plotted one of the carpets due to the density of the data, but we can easily switch between them by clicking here. Here we have the carpet view of the correlation, which could be almost seen as a top-down view of the correlation, with red being equivalent to the larger correlation values and blue to the lower. And above we can see the correlation curves in their more conventional form, with correlation plotted on the left-hand axis. Now if we want to view one or a sub-range of the correlation curves from the carpet, we can click and drag here. On the left-hand side we have the intensity time traces of the highlighted correlation functions here, and we also have a view of the raw intensity carpet which led to this data, which we can move through here pane by pane. Now we have options for cropping the carpet temporally and spatially before correlating, and we also have tools for correcting for photo bleaching artifacts. But in this particular data here we have none of these problems, so we won't cover it in this tutorial. And we also have the potential here to save out the data once it's been correlated, or the raw intensity data into a common format which can be viewed in many common image viewers. We can also toggle our carpet browser so that we can view our data in a drop-down box, and potentially if we have a lot of data we can manage that more effectively. But for now, what we will do is just export this data to fitting, which we do by clicking export to fit. We can either export all of the carpets or just one of them. In this case we'll export all carpets to the fitting. And now when we click our FCS function fitting tab, so once in the fitting tab we can now visualize our individual carpets by checking and plotting individual curves, or multiple curves, or all of our curves, like so. And then what we want to do is fit one of these curves as an example for the others. So we'll just pick one of the first ones, and then once we've selected in this list, we can say fit with parameters, current, and we'll see that our model appears. And at the moment, upon refitting, it correctly fits one of the curves, but I can see that the amplitude of this, the limit of the amplitude for the fitting is a bit low, and we can see that the amplitude goes up beyond 1.5, so I'm just going to fit this to 2. I'm going to refit, and then now I'm happy with these settings for all of the curves. I'm going to click all, and we should see the curves fitting for all of them. Now the red here represents curves which have fit but not have fit completely optimally, as in the quality of the fit is not below the chi-squared cutoff value of 0.50. So the reason for that is that these curves are possibly not ideal, So we can try refitting and see if we get a better response. But I think in this case, due to the noise of the curves, we may have to reduce the tolerance a little bit. So we'll set it to 2, so we increase the chi-squared value. And then if we fit again, we can see that many more of these curves are within our tolerance. But I can see that these curves are pretty good considering the data in this case. So I'll show one curve in particular, and remembering to uncheck these ones completely. So with this software we have multiple fit equations for different situations. This is a 2D diffusion that we're studying here. We have the option for 3D. We can also include different equations for triplets and for different types of diffusion. And we can vary the number of diffusing species and the number of triplet states. Further details of this are included in the manual for FoCuS scan. But once we fit a model to our data, then we can extract the parameters here for that fit, and we can visualize distributions between the data. So for example, with generate scatter, we can view a scatter plot comparing two of the parameters for the data. So for example, transit time versus amplitude. And we can either copy this to the clipboard or save it to a file. Once we're happy with our data, we can copy the parameters of the fit to the clipboard by clicking the parameters here. We can also copy out the raw plots and the plots for the fitting, for example if we want to make a proper figure from the data, or we can save out the parameters of plot plated directly to an Excel spreadsheet with this particular name, or with the name you specify, to the output folder that you specify. Okay, so that concludes the review of the basic pipeline of FoCuS scan. There are many more ways of dealing with the data. I've shown you from importing raw data right through to fitting the data. You can also here load previously correlated data, so you don't have to correlate and fit in one session. And you can also load whole folders of correlated data for visualization and fitting. Okay, but for more functionality of FoCuS scan, please check the manual.